Hello friends, in this video we'll see what are variables and constants. Variables are the name for memory location. So if we want to save any value in memory, we have to use memory location. So to access the memory location, we have to use variable names. So that memory location can be, if we want a memory location, that memory location can be accessed using a variable name. So if we say int x, one memory location will be allocated for x. If we say float y, one more memory location, and if say character z, one more memory location. So depending on number of memory locations, variables, the memory locations will be allocated for the program. Again, if we say x of type int, so the size of the memory location depends on the type, that is int. So in a 16-bit compiler, the size of the int variable is 16 bits. The size of the float variable is 32 bits. And the size of character variable, that's the char variable, is 8 bit. So if we say x is equal to 10, so 10 is stored in the memory location x or the variable x. We can say either a memory location or variable. So both are same. So y is equal to 45.5. So it will be saved as 45.5 0 0 0 0 0 in the memory. So it depends on compiler. So how many bits is the size of the type float? If you say z is equal to g, so g will be saved in the variable z. So g will not be saved as g in the memory, but it will be stored instead of its ASCII value. So we'll see what's the ASCII value of a character. So when we say z is equal to g, so in the memory it will be stored with zeros and ones. So computer don't understand the g as a single character. It understands the g as a combination of zeros and ones. So we'll see what that is exactly later. So the value inside the location can change. If we say z is equal to r, so g is replaced with r. So variables can change. You can change the value of the variable. So variables and constants. We have x is equal to 10. In this statement, x is a variable which can change anytime. You can say x is equal to 25 later. So 25 will be stored in x. And 10 is a constant. It's a number. It's a constant. So constants are stored in variables. So there are some rules to name the variable names. If you want to use some variables in the program, there's a rules that you should follow. There are some rules. First character should always be an alphabet or underscore. You cannot use a number or a special symbol. No commas allowed. No blanks allowed. Special symbols other than underscores are not allowed. Cannot start with a number. So there's one more point along with this. You cannot use keywords to name variables. For example, int, float, char, for, while. These cannot be used to name a variable. These are used to construct the statements, C statements. So we cannot use keywords also. So these are few rules. So the legal variable names are price with a capital P and price with a small p are two different names. So C is a case sensitive language. So if we have a variable with capital P price and you can have one more variable with small case p price, so they are different. Both variables are different variables. If you can save different values in both of them, they are not one variable. So you can also have underscore price. So this is legal because you can start a variable name with underscore. So rate of interest is also valid one. It's a legal variable names because it does not contain any special symbol. It does not contain any special character space. You can see box width is a valid variable name. It has underscore. R2 is a valid legal variable name. So R is starting with alphabet. You can have numbers, but it should start with alphabets. Again, we have T67788 is also valid variable name because it starts with alphabet. But I always suggest you to use meaningful variable names. So these are incorrect or illegal variable names. These are not allowed. So first price, it's starting with a number. So a variable name cannot start with a number. Door hash. So it cannot have a special symbol like hash. Rate dollar. You cannot have a dollar symbol. It's also illegal. You can have only underscore. Big box space width. It's also not allowed because space is not allowed in a variable name. Rate of interest. It has a dot symbol and dot is not allowed. And 67788 is also not allowed because it starts with number. So these are illegal variable names and should not be used, and you cannot use this, you will get a compiler error. Constants allowed for int. So what are the values allowed for int? So it should not contain decimal values, should not contain 5.6. If you try to give int x and x is equal to 7.9, so 7.9 will not be saved in x, only 7 will be saved and the 0.9 will be discarded. So it can be negative or positive number. So you can say minus 10, 13, plus 14, minus 14, minus 15. You can, so if there is no sign, if we say x is equal to 14, so it is assumed as plus 14. If you say x is equal to minus 10, it's the negative number which saves, minus 10. So whenever you don't put a sign in front of the number, for example, x is equal to 45, so it is assumed as plus 45. No commas and blanks allowed. You cannot say 5 space 300 and save 5300 in a variable. You cannot say 5 comma 300 to save 5300. So commas also not allowed. So allowed range is the minimum number you can save is minus 32768 and the maximum number is 32767. So these are the examples 877 and minus 999. So we'll see how exactly the values are stored in the memory. So int type is 16-bit wide in 16-bit compilers. So we assume that it's an 8-bit for right now to understand. So actually it's 16-bit. We here consider it as a 8-bit for right now. We'll assume what happens if it's a 8-bit memory each int variable is. So x is equal to 0. When we say x is equal to 0, so you can see all the bits are 0. All the 8 bits are 0. So every bit has a place value. The place value of this 0 is 128. The place value of this 0 is 64. 32. When we say x is equal to 0, all the values will be 0. So when we say x is equal to 5, so wherever we put 1, we have to add that value. We have put 1 in the place of 4 and 1 in the place of 1. So 4 plus 1 is 5. So when we say x is equal to 5, so the value which is stored in the memory is 000000101. So this is how computer understands the numbers. Computer understands only zeros and ones. If we say x is equal to 31, you can see it's 16 plus 8 plus 4 plus 2 plus 1. So you have to add all the place values where there is 1. So then you get the actual number. So whenever you say x is equal to 31, inside the computer memory, the value stored is 000111111. So we assume that it's 8-bit memory, but 16-bit memory can store more than this value. It will be like this. After 128, the next bit will be 256, and the next bit will be 512. So it can store more values. So here if we say x is equal to 44, it's 32 plus 8 plus 4. So this way the computer saves the data when you enter a number, when you save a value in an integer. So the minimum value which can be stored in an 8-bit is 0, 0, 0, 0, 0, 0, 0, 0. It's 0 is the minimum value. As we go on, increase the value like 1, 2. You can see this is the place value of this is 2, 3, 2 plus 1, 3. So we can, as we go increasing with 0 to the maximum value which can be stored in an 8-bit is 255. You cannot store more than 255 in an 8-bit variable. So this is why we were talking the range of values entered for int is 32768 minus 32768 to plus 32767. So that is the range. So for an 8-bit the range is 0 to 255. You can see the range is 0 to 255 is the maximum value that a 8-bit memory location can save. So but we want to save both positive and negative using the same 8-bit. If we want to save both positive and negative, what happens? You can see the least number is 0, 0, 0, 0. As we increase here, you can see until x reaches 127, the 8th bit. So this is the first, second, third, fourth, fifth, sixth, seventh, eighth. The 8-bit is 0 till x is equal to 127. So when we increase x value to 128, so this is 1, 0, 0, 0, 0. This is the place value of is 128 plus all zeros is 128. So until 127, the 8th bit is 0. After 128, the 8th bit is 1. You can see till 255, from 128 to 255, the 8th bit is 1. Before that, the 8th bit is 0. For all the values less than or equal to 127, the 8th bit is 0. So here the 8-bit is divided, first 127 numbers from 0 to 127 is positive, and next from here to here what they have done, they are representing the same bit locations, the bits. So they are using only 7 bits. 1, 2, 3, 4, 5, 6, 7. Only 7 bits. Here also they are using only 7 bits for storing the value, and the 8th bit used for a sign of the value for negative or positive. If it's 0, it's positive. If it's 1, it's negative. So here 8 bits are not used for storing value. Only 7 bits are used for storing value. So now the maximum value is, you can add this 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. So you should not add this one now. You should add only this one. The maximum value when you add all these ones is 127. And if it's the 8th bit is 1, you should say minus 127. You can see it's 0. These bits should not be added for value. So in 8 bits, only 7 bits must be used for checking the value, total value. Now for 127, you add 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's 164 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So you should not add the final one. Again, you can see for here, this bit is used for sign. So 1 is minus 1. Sorry, 1 is used to represent that this number is minus. We have 0, 0, 0, 0. So minus 0, minus 1. So we cannot have two zeros like minus 0 and plus 0. So they have some binary representation, 2 complements number. So we'll not get into 2 complements calculation, all those. We'll take it as a simple way. We'll assume now, so 0 is not there. We'll say this value is as 1. Okay, we'll start negative numbers here, from here 1, minus 1, minus 2. So we'll take like this. So now only 7 bits must be used to evaluate the value. The 8th bit should be used for sign. So if it's 1, it's all from here it starts 1, 2, 3. So it goes up to 128. So we cannot have two zeros. Hence the minus 0 is considered as minus 1, and minus 1 is considered as minus 2. Minus 127 is considered as minus 128. So this way the maximum value stored by 8-bit is 127 and the minimum value stored by X is minus 128. So we should use only 7 bits to calculate the total value, and if the 8th bit is 1, it's a negative number, and if the 8th bit is 0, it's a positive number. So this way 8-bit can store value from minus 128 to plus 127. That's minus 128 going towards 0 and then going towards 127. So this is the range of the 8-bit value. For an integer, it's 16 bits, so the range is minus 32768 to plus 32767. So the primitive data types available are int, signed int, unsigned int, long int or long, short int or short. You can also say is that simple as long or simple as for long int you can say long int or just long. For short int you can see the size of the data depends on the type. If it's an integer int, it's 16 bits. If it's a signed int, it's 16 bits. Unsigned int is also 16 bits. So if you use a signed int, then the range of values allowed is minus 128 to minus 32768 to plus 32767. So if we are using unsigned int, so here we are not using positive and negative numbers. The value will be 0 to 65,535. So here it will be the 16 bits will be used for only positive numbers. Float is 32-bit, double is 64-bit, and character is 8-bit. So this is according to the 16-bit compiler. The 32-bit compiler, the size of these variables, this data type will be different, will increase. So this is according to the 16-bit compiler. So constants allowed for float. So should contain decimal. You can save 7.9 in a float variable. It can be positive or negative. If there is no sign, it is considered as positive. No commas and blanks allowed. So allowed range is, this is in the form of exponential form. So the allowed range of values is minus 3.4 exponential to the power of 38 to the plus 3.4 exponential to the power of 38. We will not worry about this range right now, the float. So we have examples 8.97 minus 999.88. So we can store these values, the decimal values in float. So constants allowed for character, that is, you can use all the characters that's available in the keyboard. So the more ASCII, only the ASCII characters are allowed. So ASCII characters are a list of characters provided by American Standard Committee for Information Interchange. So for whenever we say A, we save A in a character variable, it will be saved as a number. We'll see what the numbers are exactly, what's the ASCII number saved for A, what's the ASCII number for star, ampersand, everything we'll see later. So we'll see some programs now. So here is a simple program which we already seen. So I'll say this time I'll start with integer int a. We'll say the variable name is a, and we'll say enter the value. Okay, we'll not use scanf statements right now. We'll use simple programming we hard code the values inside the program. That is a is equal to, if I say 19, you see value of a is equal to %d . Okay, I'm just printing the value of a. I'll do Alt F9 and I'll do Control F9. You can see it says value of a is 19. So what happens if I say the value of a is 19.77? You can see I'll say Alt F9 Let's say control F9. You can see it's again says value of A is 19. So it will not save the decimal values. So int variable type variable cannot save the decimal values. It will discard this 0.77 and will save only 19. So you should be careful. So if I say 32767, okay, we'll say 32767 or F9, control F9 says value of A is 32767. So whatever value we entered, so it's showing the same value. If I say 32768, you see what happens? I'll say Alt F9. See, it's giving us a warning. So you can see. So we forget about the warning and we'll execute the program. You can see it says minus 32768. So what happens? So whenever we want to save a value which is greater than 32767, so it comes back to the negative side. So if we say 32769, I'll do Alt F9. So we'll not worry about this warning right now. So you can execute the program even if it has a warning. Let's say you can see it's going back. It's like a circle. If you increase on a positive side, the number changes on the negative side. So it's very important that you store correct values in the integer. So there is a range for integer, there's a range for float, and there's a range for character. For everything there's a range. So what happens if we do a calculation here? We'll see. Now this is how you can say the maximum positive value is 32768, or if you want to save minus 32767, so it's the minimum value which can be saved in int. I'll say Alt F9. I'll say Control F9. You can see it saves minus 32768. So there's no problem. But what happens if you save a value less than that, the 32769? So Control F9. You can see it's going towards positive. So if you exceed the range, so it comes back on the other side. If you say 327670, I'll do Control F9 to run the program. You can see it's coming on the positive sides. It's coming reverse on the positive side. So this way you cannot store a value less than minus 32768 and value greater than 32767, positive 32767. So you should be careful about this. So we'll take one more variable of type float. So A is equal to 5.67. So we'll see, we'll compile Alt F9. We'll do Control F9 to run the program. You can see, so it saves as 5.670000. So this compiler uses 6 decimal places by default. So this is the width of the decimal places in 16-bit compiler. So if we save 5, what happens? Alt F9, Control F9. You can see it saves as 5.000. So whenever you use integer, you assign an integer value to a float variable, so it will promote that integer to the float value automatically. So this way, the compiler saves the data in the memory. So if we use a character variable, so this is one of the interesting program now. So if we say character, if we say I want to save a, you have to use single inverted commas. The value of a is, okay, so I'll say Alt F9, I'll say Control F9. So you can see the value of a is a. So what actually is stored in the memory is different. If you do a percentage %d here, okay, if you say percentage %d, it will show you what exactly will be stored. Control F9, you can see it stores 65 because 65 is the ASCII value of capital A. So you can save some other value here. If you say small a, the ASCII value is 35 for small a. So I'll say Alt F9, Control F9. Oh, sorry, it's 97 is the ASCII value of a, small a. So if we store a star, it's a symbol, it's a star character, or asterisk character. So we'll do Alt F9, do Control F9. You can see 42 will be saved here. So this is the ASCII value will be stored inside the computer memory. Even if you are saving a character, a number, you try to save a number here. Control F9. You can see it says 6 directly. If you try to save 6, it stores 6. And if you try to print this as C, you can see a hyphen is being printed now. So if you add a 65 here, you do Alt F9 and Control F9, you can see A is being printed. So this is the ASCII value. If you get an ASCII value directly here, so if you put as a character 5, so it assumes as a character, and we'll do Alt F9 and Control F9. So you can see it says 5 is inside the A variable. So if you want to the value ASCII value of 5, you have to use D, percentage %d. You say Alt F9, Control F9. So when you say 5, so 53 will be saved in the memory. You can see. So computer will not use the character A or asterisk or hash symbol. It cannot directly store those values in the memory. It cannot directly store A. It cannot store B directly. It has to store in the form of binary zeros and ones. That is the ASCII value of the character. For every character in the keyboard, the computer saves it in the form of zeros and ones. Friends, in this video we have learnt about variables and constants. We'll learn more in the upcoming videos. Thank you for watching this video.